how do we get to fusion versus fission, nuclear fusion versus nuclear fission? So we're talking about the nucleus either falling apart, that's fission, or taking two small nuclei, fusing them to produce one slightly bigger nucleus through fusion. In fission, they take much bigger nuclei, and those can fall apart. They can do it spontaneously. Of course, when we're trying to produce energy, we stimulate the reaction, and energy comes out when a big nucleus falls apart. In fusion, they take very light nuclei, and when those very light nuclei fuse, turns out energy is also released. So in both cases, energy is released. There has to be lots and lots of particles flying around and sort of interacting, running into each other lots and lots of times. Just a handful of the many, many, many interactions actually result in a fusion. Fusion typically happens in a plasma. To get fusion energy, especially here on Earth as opposed to on the Sun, there are lots and lots of things that have to go right for us to be able to extract energy in a continuous, sustainable, predictable way. There's two traditional approaches. One is to try to hold that plasma with magnetic fields. Plasma is hot. You can't touch it. So the first big challenge is to hold the plasma steady long enough, high enough density, and high enough temperature. The challenge there has been, of course, to keep that long enough. So in that case, it's called magnetic confinement. Another approach, they usually do that with lasers. They take a solid target, and then you shine as many lasers as you can get from all directions onto the target, sometimes directly, sometimes indirectly. And in the end, you compress it, you ionize it, so it becomes a plasma. But you do it for a very, very short time. So it's not, you don't hold it for seconds or minutes. It's for a tiny fraction of a second that you have this tiny little explosion. And then you do that many, many, many times a minute. Some research into really old scales, just about old scales. I have not really heard of fusion engines for cars yet.
Wait a minute, what are you doing, Doc?
I need fuel.
The more traditional approaches has been the big power plant for energy production. There are many concepts are working on more compact reactors to power a small city. There's also concepts for fusion reactors for space propulsion. There's a lot of work to do, but the concepts that are out there could be promising for deep space travel. There's a little bit of everything that people are trying, because if we can ever get there, it is a very bright, promising future.